Okay, so in this video, I'm gonna go over a famous problem that confuses a lot of people, sometimes referred to as the boy-girl problem. And essentially, suppose you have a town where every couple has exactly two children, and every birth is equally likely to result in a boy or a girl. And now the question, which leads to the weird example that fools all these people, is suppose the couple has a girl. What is the probability that they have two girls? Well, we could say that this is a conditional probability question. Probability A given B, where B is they have a girl and A is they have two girls. Okay, so we define our sample space. Our sample space is the outcomes boy, girl, girl, boy, 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 and girl, girl. So the cardinality of our sample space is 4. For B, our set is the set of outcomes for which the statement they have a girl is true. Well, here we have boy, girl, girl, boy, and girl, girl. In each one of these, the statement they have a girl is true. It is not true for the outcome boy, boy. And so the cardinality of this set is 3. Now the set A, they have two girls, is actually rather straightforward. It's just girl, girl, and so the cardinality of that set is A. Now, A intersect B, or A and B, is just girl, girl, because that's the only element that's shared between those two sets. We have B having this one and A having this one, and so that's going to be 1 as well. And so if we write out the definition conditional probability of A given B, we can write that as P of A and B divided by P of B, which we can calculate as the cardinality of A intersect B divided by the cardinality of S divided by the cardinality of B divided by the cardinality of S. And working those out, as we have here, we know that that turns out to be 1/3. Now, we can change, so this is completely counterintuitive because we know that boys and girls in this town are born with equal likelihood, and so the fact that a couple has a girl shouldn't really change the likelihood that their other child is a girl, but it does, and part of the reason why is because we don't know which of the children is a girl. We just know that one of them is a girl. We don't know if it was the first one or the second one. So let's change this question a little just to make the world make sense again. Suppose the couple's first child is a girl. And now we're going to ask two different questions for those of you that might think there might be some semantic tricks here. I'm going to actually ask two questions here. And the first question will be, what is the probability that they have two girls? And the second question is, what is the probability that their second child is a girl? And in both cases, we're going to be able to define our sets B and A fairly easily. In both sets, the probability, we have the statement, suppose the couple's first child is a girl, and so any outcome which has a G, which starts with a G, will meet that criteria. And so for B, we have in both cases GB and GG. Now in the first question, the question is, what is the probability that they have two girls? Now that outcome is just GG. And the second question, what is the probability that their second child is a girl? Now that set is boy, girl, and girl, girl. Okay, so now we have two different sets, but two different ways of asking the question, but I'm going to show you that it's essentially asking the same question because when we take the intersection of A and B, we notice that the result is the same because the only element which is shared among the two sets is girl, girl, because boy, girl is not the same as girl, boy. And so we have here A intersection B, in both cases, is girl, girl, which has cardinality 1. And so if you do that calculation that we did above, which in this case I kind of did it really, with a lot of steps, but essentially it's going to be the cardinality of A and B divided by the cardinality of B. And in this case, the cardinality of B is 2. Cardinality of B is going to be 2. There are 2 elements in B. Cardinality of B is 2 in this case as well. And the cardinality of A and B is going to be 1, and in this case as well, A and B is going to be 1, which gives us the answer that makes us feel better and sleep well at night. That the probability of their second child is 1/2. Hopefully that was clear and helpful. Have a nice day.